My name is Abdel. I'm actually based out of Stockholm. I was coming here for a. Oh, thank you. Great. Awesome. Thanks. I'm coming here for an event tomorrow, and then I reached out to Rustam and said, "Hey, can we do a meetup? Because we have budgets now, so we have to prove that we have to travel for something useful." So then my director was like, "You're going to meet the customers and meet a community. That's good, proved." So I'm a developer advocate. So my job really is doing this: is going around talking to communities, talking to people, doing talks, producing content. One of the stuff I work on is the Kubernetes podcast by Google. Is anybody here listening to it? 3 people, 4 people, 2 outside and 2 inside. Okay, so it's a podcast that we have been running for about 5 years now, and we mostly cover everything Kubernetes, but also cloud native. It's a pretty cool show. I would highly recommend to sign up. I've been at Google for 9 years, 9 years and a half, roughly. I've done a lot of things. I started actually initially in the data center in Belgium, Europe West 1, the region. Have anybody deployed there anything before? 1, 2 people. So I was actually based in that data center, but I was there before cloud happened or cloud existed. So if you had a virtual machine that suddenly disappeared, it was not me. Then I moved to Sweden. I worked for something called Professional Services, which is like an internal consulting part of Google. So we're actually working with external companies, helping them use Google Cloud. And I picked up Kubernetes and Service Mesh. That's sort of my focus area. And now I'm a developer advocate. So I get to talk about stuff. I don't really know how stuff work. I just know how to talk about them. And so today we're going to talk about this thing that is kind of making the rounds recently called software supply chain security. But generally speaking, I'm going to talk about what do we mean by software supply chain security and what do we have on Google Cloud as products that would allow you to implement this practically. So I'm going to do a lot of demos. There are a couple of slides I'm going to go through just to present what the products are, but this is a very demo-heavy talk. Everything is going to be using Google Cloud. Everything I'm going to be using today or showing today is actually available, so you can just use it. And I'm going to also show you what we have on Google Cloud, but also something open source. So you don't really have to be on Google Cloud to use these tools, right? I want this to be as interactive as possible. The group is small, so don't hesitate to raise your hand and ask me a question. I can show you things, even if it's outside of the scope of the presentation. But before we move on, what is software supply chain security, or what is software supply chain? Well, how many people are developers? Can somebody tell me roughly what do you think is the percentage of code that you write versus code that you pull as dependencies? What 10, 90%? 90% being dependencies, not the other way around. 10% own code, 90%. Yeah. There was an article written by somebody a long time ago. I don't remember. I remember reading an article that said 3% is people writing their own code. I don't think there is any facts about that. It's not a data-based assumption. I think it was just pull the number out of the air. But yeah, typically when you write code for any company, even at Google, we're not writing all our dependencies, right? No one is gonna rewrite an HTTP library. You just pull that HTTP and use it, right? So realistically, when you are writing code, your code source is code you write yourself, and then tons of other dependencies you pull from the internet. You build that, you ship it to your production, and you move on, right? And for a very long time, security in IT in general was mostly focused on the runtime part, right? We were making sure that no one can get into our runtime, no one can get into our production. That's why maybe your company has something that scans when you accidentally submit SSH keys to your source code, or you have somebody in your company doing black box testing, which is essentially just considering your production system as a black box and trying to hammer it to see if they can get in, can they steal something, can they expose a debug port or something like that. And we got really good at it, right? We got really good at securing software at runtime. That's why it's pretty rare. It still happens, but it's pretty rare now that you hear, oh, somebody left a random 22 ports open on the internet, and then somebody SSH through it with a password, username, password, admin, and stole something, right? It still happens, but it's quite rare. But what's happened is, through the years, the people who are trying to attack us, who are trying to hack you, they got so clever, and they realized that actually getting your software to production is not the only part of the story. The story really starts at your developer environment, at your computer, your laptop, your, whatever it is. And and then your dependencies that you pull from the internet, and then you like the way how you build this stuff and how you package them and how you ship them to your production system. And they started looking into how can they poke some holes into this entire workflow. And that's why we call it actually software supply chain, because the way we ship software to production is pretty much the way you get your food into your table. Food starts in a farm or in a factory, and then it gets through a bunch of steps before it makes it to your table. So if I am a malicious person and wants to infect a group of people, well, instead of trying to put poison in the food which is on the table, I can just start early in the process and try to inject my bad stuff somewhere in the process, right? And that's kind of the similarities between supply chain as the way how we get stuff into the table, how we got food into the table, and then software supply chain. One of the and even those dependencies that you also depend on, they're also software. So they have their own sort of like software supply chain process to get them into where they are used. So it's sort of like a nested doll type situation, right? And one of the early attempts to exploit this, I don't know if you remember this a few years back, somebody managed to get committer access to the source repository of Homebrew. So Brew, the software that you use to install Mac software. So somebody managed to get themselves, so the person was a researcher, security researcher, but he managed to prove that he can get committer access to the repository, the GitHub repository, which hosts the code source of Homebrew. And once you are a maintainer, you know what happens. If you don't have branch protection for your main branch, well, you can just submit and commit code without needing a pull request and without needing anybody to approve your code, your change. So you could just infect software that way, right? And that probably was the first time this whole concept of software supply chain security came into existence, although it was not called like this before. This is just an industry term, maybe more like a marketing term that really doesn't mean anything. It's more like, it's basically like DevOps. What is DevOps? Well, DevOps depends on what the company does with the term DevOps. Just a few numbers for you. I'm not going to go through all of those, but some of the recent attacks that we can talk about are Log4j. I think everybody remembers this one. SolarWind is the vulnerability that attacked the pipeline, the whatever gas pipeline in the US that kind of supplies the East Coast with gas, and somebody managed to hack the company through a software called SolarWind. One that is closer to home is Kaseya. So do you know the retail chain called Coop in Sweden? Do you have it here in Norway? Yeah. Oh, you have it, yeah. So I think it was either last year or the year before, they shut down their stores for 24 hours because they use Kaseya, which is like an asset inventory software. And somebody managed to hack Kaseya, not hack, somebody managed to hack like a dependency that Kaseya used in their software. And so they pulled that dependency, they built the software, and then they supplied it into their own clients. And one of the customers that were impacted was Coop, right? And they were basically down for a while because somebody encrypted their hard drives and asked them to pay with Bitcoin or whatever that thing was. So I talked earlier about this concept of nested doll, and essentially what the point I'm trying to make there is, if you are a malicious attacker and you want to attack somebody, instead of going directly to your end user, your end company, your end customer, your end organization you're trying to attack, you can either try to attack them through their software supply chain process, or maybe through the software supply chain process of a software they depend on, right? Something they just buy off the shelf and install. I can give another example, which probably you remember, is a few years back, there was this massive thing that blew up on the internet. No one managed to prove if it was real or not, but the name was Supermicro, the company that makes hardware. They make like motherboards and mostly motherboard servers. Somebody like spread a rumor that because they manufacture this stuff in China, somebody can inject like bad software in the firmware of the servers, right? And because Supermicro is not a company, they don't sell servers branded Supermicro. Their products are white label. So they make motherboards. Other companies buy their motherboards, put CPUs and memory in them, and then sell them as another hardware, something, right? Sometimes not even servers. They sell them as either routers or switches or whatever, right? And so this also sort of raised a lot of eyebrows in the sense that, well, no, we are actually vulnerable in more places than we think, right? And that's the whole concept of this software supply chain security concept, right? So the idea of software supply chain is to just look at the whole process we use to supply software to production, and look at every single step as a potential attack vector, starting with it could be as simple as an internal malicious user injecting bad code into your source code. This could happen. There are a lot of companies that doesn't do peer reviews. There are a lot of companies that just allow people to submit code to their code repositories without really worrying too much about security there. I think we have just assumed that as IT professionals, we are trustworthy. So when you hire a developer, you don't assume that they are potentially going to be an attacker, but that could be the opposite, right? Then somebody could compromise your source control, right? You can accidentally leak an SSH key, and then somebody can find that SSH key and then dump your code. You could even accidentally, now there is one common thing, which is there are a lot of platforms that allow you to host a static website where the code source is based in Git. And if you are not careful enough, you could just expose your .git folder, which contains a lot of things, including your commit history, which if you accidentally committed a password, it's in the logs. So if somebody finds the logs, they can find that password or that API key or whatever. Somebody could also compromise your build system. I think over Christmas last year, one of these famous managed CI tools, like manage SaaS CI, I'm not going to say names, but a famous one, got actually hacked. And it took them like 3 weeks to realize it. And then it took them 3 weeks to actually inform their customers, to tell them like, hey, if you have accidentally committed AWS keys, it was mostly like AWS kind of secrets into your code. Well, we have the logs, so we logged them and we thought our logs were safe, but somebody managed to get to our logs, right? So be careful, rotate your keys. Took them 3 weeks over Christmas. Everybody was just drunk and full with food. So that's kind of thing, right? You could also compromise where you store your software. This is actually pretty easy to do nowadays with things like Docker. A lot of people think Docker is magic. It's a glorified zip file. Like you can easily take a Docker image and zip it, or unpackage it, change the layer, zip it again, and then upload it again, and no one would realize that, right? If you don't, this is actually, I'm gonna show a very simple demo for how these things can be avoided. Typically, the way you can avoid it is you sign your artifact. So once you build your artifact, you just sign it with a key, and then you can verify the signature along the steps of going from developer environment to the production, et cetera, et cetera. So basically, the point is there are a lot of places where people can attack you. And this whole realization of we are vulnerable in more places than we think started this new movement, which I hate the word. It's called shift left. Shift left essentially means, why don't we actually think of security as everybody's responsibility and try to move the way we think or we reason about security toward the development environment? In other terms, let's make everybody responsible for security, which a lot of developers hate because you don't care about security. That's the point of being a developer. You just want to build software, right? I think a much better term for it would be, now I forgot the term. Like there is a much better term. I'm going to remember it at some point. But the idea would be, instead of just making everybody responsible for the security of your software, you make everybody aware of what they're doing. So instead of just dumping the responsibility on the developers and on the operators and on everybody involved, you give them tools so they can see what they're doing. A very simple one could be give people a way to scan their code source, right? Early in the process. Maybe something integrated into their IDE. Maybe like they can look at their IDE, and then the IDE could automatically resolve the dependencies and tell them like, hey, this thing has vulnerabilities. So they look at it and they're like, oh, maybe I should upgrade the package or something like that. So there are ways where you can make everybody responsible and accountable for security without just isolating a group of people and saying like, well, now it's your problem, right? And then there is the other concept of zero trust. So zero trust as a concept is coming from the networking world. The idea of zero trust essentially is this concept that network security for a very long time have been firewalls and DMZs and authentication. In other terms, I have a house, I want to secure it. I'm just going to build very tall walls. I put like, wire over my wall, and then I'm safe. That's your firewall. If somebody breaches over that security layer, they are inside your house, they can just easily go from one room to another, right? The whole concept of zero trust is that security in a system starts from the inside, and the way you would secure a microservice system is make every single microservice authenticate and authorize itself when it talks to another microservice, right? In other terms, once you are inside the distributed systems, you don't just trust blindly that everybody is a good actor. That's the whole point, right? But what I'm not going to talk about, I'm going to talk briefly about zero trust when it comes into software supply, and that's the demo about signing that I'm going to do. So I'm not going to bore you with the networking stuff because no one cares about that. This whole realization gave birth to something called Sghiouar. So Sghiouar is like a consortium. It's a group of companies that are together, putting their efforts, hiring people, and putting them together to work on concepts of software supply chain. And they do three main things. They build either frameworks, so like things to follow, or software, things to use, that allow you to sign, verify, and monitor. So the sign part is the zero trust thing I talked about, signing artifacts, so to make sure that when you deploy something, you trust that it's coming from a proper source. Verifying is making sure that the stuff you have signed is signed properly. And then monitoring is making sure that the software you are building and you're supplying is not vulnerable, right? So one of the things that Sghiouar came up with is this thing called SLSA, which starts for SLSA. I don't know what it starts for. Software Level Security Assurance. Essentially, what SLSA is, it's a set of practices. It's a framework that goes, if your build and deploy pipeline is meeting the requirements for level 1, then it's SLSA compliant level 1. If it's meeting compliance for level 2, then it's SLSA compliant level 2, etc., etc. These are not technologies. These are just set of practices. How do you implement them depends on your system, right? The whole point here is, if we take SLSA level 3, it says for basically when you build the artifact, you have to attach metadata to the artifact that says how these artifacts have been built. What are the libraries that have been used to build this artifact, and who built the artifact, right? When you store your artifact, you have to attach what we call an SBOM, a software bill of material, which is essentially a metadata payload that describes every single dependencies inside that specific artifact. Things like that. So this is SLSA, and I'm going to show you how we implemented this in Google Cloud at some point. And then they have a bunch of tools, a bunch of open source tools. I'm going to show you Cosign today. It's like the first tool, or one of tools I'm going to show quickly because it kind of plays very nice with Google Cloud, generally speaking. And with that, actually, I can get to the demo. So, oh no, before, I know, yeah, okay. Let's do the Cosign demo very quickly. How many people here use GKE or Kubernetes? All right, few people, okay. All right, let's start with something simple. I'm going to try to make it as simple as possible. So even if you don't really, you're not actually Kubernetes or a GKE user, you would understand what I mean. So what I have here is I have a Kubernetes cluster. I'm going to show you real quick. It's coming. All right. I just have a Kubernetes cluster. It's deployed in Finland. It doesn't matter. One of the most powerful things about Kubernetes is one of the things that actually makes it very dangerous. And I'm going to do something, and you tell me what do you think what I did, whether you think what I did is a problem. So I'm going to just pull an image from the internet, right? Nothing wrong with this, right? So I'm just pulling.
Where are you pulling it from?
From the internet. It's the most safe place on earth, right? So I'm just pulling a random Docker image, Nginx, right? Sorry? Well, I did not specify which Nginx I want, so it's whatever is docker.hub, dockerhub.io/Nginx, whatever that thing resolves to, right? Okay, so now I have my Docker image here. It looks good. It's small. So what I'm going to do is I'm going to try to deploy it to Kubernetes. If you don't know anything about Kubernetes, simply if you want to deploy something, you have to make that image available in an artifacts registry so that the cluster can put it. On Google Cloud, we have two artifacts registry. We have something called Container Artifacts Registry, Google's GCR, and we have something called AR Artifacts Registry, which is the new one. You don't have to worry too much about it, but what I'm going to do is I'm going to push my image to the container registry and then deploy it to my cluster. I have to do that because right now the image is on my my laptop, right? I cannot just push it to a remote cluster. So again, don't have to worry too much about the details of this. I'm just going to set up some variables here. I'm going to tag my image. This is basically how I would push it. I have to tag it with like a specific tag, and then I'll just push it to the internet again, right? So so far I just pulled an image, and I put a tag on it, and then I pushed it, right? No, sorry. Okay, so this is pushing the image to my container registry remotely. And this is typically what a developer would do if you ask them to deploy software on GKE, right? You just, hey, I have a Kubernetes cluster, run a Postgres SQL. This is what they will do. Put an image, tag it, push it somewhere, and deploy it. I'm not using Postgres because I don't care. I just want to deploy my image. So I'll just go to my artifact registry and pull the URL for that image. It's here. So I'm just going to go here, take the URL, and simply I will just deploy it into my container registry, right? Okay, kubectl gets pods, and my container is being created. Sorry. Right, it's running. My container image is running. Anybody have a problem with this? Yes?
So one problem which I can think of is this: by default, you put the default nginx base image, and that has root user configured for it to run.
That's a very valid point. Yes. Okay, that's one problem.
That's one problem. That is, it's using a root user.
Yes. Yeah, that's what can go wrong. Somebody else thinks about something else. That's actually a very valid point. Yes.
The other one is that, well, you pull latest, so you have no idea what you're actually getting.
That's actually a very good point. Do not use latest tag. Good. Anybody else? Well, I just pulled stuff from the internet. I don't really know what it is. I don't trust it. I don't know how it was built. I don't know where it's. I don't even know what the source is. I just said Docker pull Nginx, and Docker did some magic and give me an Nginx image, right? So now, how can we solve this problem? I'm still going to use the same container image because I'm too lazy to build one. But let's just assume that this is you building your own container image and making sure that from the moment you build your container image locally on your laptop, all the way until the moment it's deployed on the Kubernetes cluster, along the steps, this image can be verified, right? We can verify that it's me, the developer. Typically, you don't do this in your development environment. You do it in your CI. So you build your container image the first time in an automated way, and then you have your CI attest that this image has been built by the CI. How can we do that? One easy way to do it is using something called cosign. So what cosign is, it's a command line tool that takes an artifact, a container image. It usually only works with container images. And then it takes a key, like a cryptographic key, like a asymmetric key that's used for encryption and decryption. And it takes that key and signs the image. And the signature is attached to the image as metadata, right? So whenever that image is used, we can read the image itself, but we can also read the metadata which contains the signature, which means that at any step in the entire CI/CD pipeline, I can easily use cosign to say, this is the key, this is my image, verify the signature, right? So I have cosign running on my laptop. Cosign itself is cloud agnostic, so it does support whatever key you want. It can work with your own key stored in your own vaults. And when I say vault here, I don't necessarily mean HashiCorp vault. It can be whatever vault you have, or it can use a cloud-hosted key. I have in Google Cloud, we have something called KMS, Key Management System, and we can use that to create key and use them, right? So KMS is two things. It's both a vault where you can store keys, but it's also a way for you. It's an API that you can use to make encryption or decryption calls, right? So I've already created the key, so I'm not gonna create it again because that takes a little bit of time. I'm gonna show you. So I have a key here, which is running in Finland. It doesn't matter. It's an asymmetric key. You see the purpose, and it's using a software protection. I can also get hardware protection if I want to use an HSM, like a real hardware security module. Pretty much the thing where you store your Bitcoin keys. That's an HSM. I can use that. So I have a key, right? So how does cosign work? So it's very simple. All you have to do is, I'll have to delete that image. Just give me 1 second. So I'm going to delete this image here. So I still have my image locally. It's this one. So I'm going to push it, but this time I'm going to grab the SHA. So the SHA is the signature, right? So I'm going to push the image and grab the SHA-256, which is the unique signature of this image. One of the best practices when it comes into image management, especially when you're doing Docker or artifacts in general is always tag the image or tag the artifact with the SHA, because the SHA is unique to the specific artifacts. If you change a single thing in the file, like a single comment or single line of code, then the signature will be different. It's not technically a signature, it's checksum, but the checksum would be different, right? So I have just pushed an image and I grabbed its SHA. So if I go here and refresh, I have it. I can actually show the SHA, echo $SHA. So this is the unique checksum. And now what I'm going to do is I'm going to assign it. So how does it work? Well, I just have to run cosine. I have to run cosine. I say sign. I have to specify a key. You say that it says GCP KMS. That just says use a GCP key management system key. Again, it could be AWS, it could be Azure, it could be whatever. And then the link to my image. So this is the image path. So what this will do, it will take the image, it will sign it with the key, and it will attach the signature as metadata to the image itself. Another fun fact for you, if you have never worked with images, container images are two things. They are files, glorified zip file, and JSON payloads, right? So the signature itself is just attached as a JSON payload to the image. So if I refresh here, you see I have a new thingy. So if I click on it and I go to the manifest, I have my signature here. So this is the signature, which was the result of signing that image with my key, right? Now, what I can do is, let's say that this part was done by my CI pipeline. My CI pipeline built an image, signed it, attached a signature as metadata. So if next step is I'm doing QA or I have to do a deploy pipeline, so I have to deploy this image, then you can have the deploy pipeline also verify the signature of the image. So I'm going to show it locally, but you can do this in a pipeline. So I'm just running cosine itself again to verify the signature of the image, right? So again, I tell it which key to use, which image to use, and it says here that the signature was verified against the specific public key. So this image have been verified that it was signed by the key I said it was signed with. Now, how can I get this into, how can I make sure that in my production environment, which is my Kubernetes cluster, I can, or I make the cluster verify the signature of the image before it lets it be deployed. Kubernetes has a concept of admission controllers. So without going too much into details, you can think of an admission controller as a gateway, as a gatekeeper, a police officer standing between you and the cluster itself. And whatever you tell the cluster to do, if the cluster has an admission controller registered with it, and the cluster is configured to verify or to run whatever you are trying to do by that admission controller, it will call the admission controller. It will say, hey, can you verify that this is possible, this is doable? And then the admission controller returns a yes or no, right? So the guys who wrote cosine, they wrote an admission controller for it. So I already deployed it, so I'm not going to go too much into details. But basically, the way I would configure it is I create a policy. And this policy, come on. What is my policy? Here we go. So my policy here, what it does basically, I'm going to show you this in details. It's a cluster image policy. It has a name, private signs, whatever. It applies to all the images. You see globe star star basically applies to all the images. You can also make it apply to a specific namespace or to apply to a specific workload. And then it has it says authorities. So that's the key, and it has the link to the key. It basically says before you let this be deployed, verify it was signed by this key, right? So then I'll create this. It was created. So what I'm going to do is I'm going to actually, there is one more step I need to follow. I will create a namespace. Again, namespaces in Kubernetes are just a way to group resources, just like a way to structure objects inside the cluster. And then I have to add a label. This is part of how this admission controller works. You have to label it to say policy.sixstar.dev include true. This allows you also to have flexibility in a cluster if you have a namespace where you don't want to verify signature. So you have a policy that applies on the entire cluster, but you just want to exclude one namespace. You can apply a tag that says include false, and that's it. You can exclude that namespace. So now I'm going to try to do the same thing I did earlier. Remember, just putting an image from the internet and deploying it. I'm going to try to do this, but now I'm going to do it in a more dangerous way. I'm going to deploy directly from GitHub, Docker Hub. So basically the same thing I did earlier, except that in the image, you see I just said Nginx. So this essentially will attempt to pull an image from Docker Hub, and it should fail because it says, well, this image is not verified. I cannot allow you to deploy it. So now I will try to deploy the image I signed earlier. So that's the image that I signed and hosted, and this one will be deployed, right? So this one is fine because it's signed, it's verified. Does this make sense? Any questions about this? It's pretty straightforward, right? All right, cool. So that's cosign, or that's kind of one of the things. Yeah.
How can I do that across organizations? Because this works internally, that's great because you have access to the key and so on. But how would I do this?
Across organizations, as in.
I publish something on Docker Hub.
Oh, you can publish the public key on. Well, hold on. You are the one publishing. Yeah, you are the one publishing images on Docker Hub, and you want people to verify that the image is coming from you. Well, you publish your public key, like a PGP key as well. It would work with PGP, whatever cryptographic key, doesn't matter. The key doesn't have to be in KMS, because in this case, I'm using KMS, so I have some IAM permissions that allows things to talk to each other. But in your case, I would probably just put it on Docker Hub and just publish my key in my Docker Hub profile, saying this is my key. Or put it, like, it's a public key, so it doesn't matter, right? So that would be an easy step to do it, I would say.
Can you add multiple keys there? Can you allow?
Can you sign the same image with multiple keys, you mean?
No, can you allow images to be pulled that can be signed by either of them?
Yes, you can, because you can add as many metadata as you want. Yes, correct. Actually, back to your question, I forgot this. Part of the things that Sghiouar provides is a certificate authority. They have a CA. So you can use their own CA, which is like a hosted thing. It's basically like a source manager or like a Let's Encrypt. So it's sort of like Let's Encrypt, but for artifact verification. So you can also use that to sign the images, and then you have a link to your key that people can use to verify the image. Yeah.
Is it working GitHub Enterprise?
Sorry?
Is it working GitHub Enterprise?
It will work anywhere. It doesn't matter. Like, yeah, as long as GitHub Enterprise can reach the key, wherever that key is hosted, it would work.
So this cosign is open source too.
Yeah, cosign is open source. Yeah, everything I use so far is open source, except, well, nothing is now. Well, Kubernetes itself is open source. I just use the hosted version, but everything I use is open source. Yeah.
But no one is there to run Kubernetes without managed service. Problem.
Well, you can. You're just gonna have a lot of problems, but you can. All right, so let's move on. So what we have done last year is we released this thing called Software Delivery Shield, SDS. And really, SDS is not a single thing. It's multiple products that we have bundled under the same products and under the same umbrella called SDS. Essentially, it's a set of features that would allow us to... That screen is flicked. Okay, so it's a set of things that will allow us to develop, supply, CI/CD, and runtime. I'm going to go through those quickly. Starting with the development environment, we launched something called Cloud Workstations. It's a fully hosted workstation in the cloud. It comes with a lot of IDEs. The base one is Visual Studio, the open source one, Visual Code, and then it has IntelliJ, PyCharm, PHP Storm, bunch of those. It works fully in the browser, but you can also use a local client, and I'm going to show you this later. You can have like a local heavy client that connects to a remote workstation. This way, you can, whenever you have internet, you connect to your remote workstation, you do your work, and then when you are done, you disconnect, and your code is not stored in your laptop. You could literally even use a Chromebook. You don't have to use a MacBook or like a Windows computer, as long as you can install the clients, or if you prefer to work in the web, you can. So this is actually sort of the first step to not be vulnerable, is not have people dump code on laptops that are randomly going all over the place. A very common way, and I'm not here advocating for you to do this, but if you really want to steal code from companies, it's not that difficult. Just go to a conference where a bunch of people from that company are going to be, and just sneak into the hotel room and then steal their laptop. Most companies don't encrypt the hard drive of their developers. Most companies don't have any policies for secure passwords. You don't even need the password as long as you can extract the hard drive from the thing. It's disturbingly easy to get access to other people. Well, if you have MacBook, you have to actually set up encryption on the disk. It's not by default. You have to set it up. It's not by default. You have to turn it on.
Very often would ask you if you want to, and I mean, if you are.
Yeah, I set up my MacBook recently. You have to say yes during the setup process. I mean, you will be surprised how many companies don't do that. Yes.
There is even easier way. Just be hired.
Yes, as well. Very valid. I like the way you think. So the easy way to not have your open source code or your closed source code stolen is just not have it on the internet or not have it on somebody's laptop.
Other ways as well, like USB keys that you can plug into, and then which acts as a keyboard
Or you can set up like a
physical access, then it's easy.
yeah, or you can set up like a double twin or an evil twin access point, right? You can set up yourself an access point that looks like the conference access point and sniff everybody's traffic. So there's a lot of ways basically you can steal things from people. The easiest way for people not to have stuff stolen is just to have them on their laptops or on the internet or on the cloud. Well, not on the cloud, but you get the point. So it comes actually pre-deployed with something called Cloud Code Source. Google Cloud Code is an extension for Visual Code and for IntelliJ that allows you to do a lot of integration, so you can actually deploy to Cloud Run, deploy to GKE from the IDE. But it has something called Cloud Code Source Protect, which essentially continuously scans your dependencies and show you vulnerabilities in the bottom. It's not very clear, it's very small, but essentially a tool that will continuously scan your vulnerabilities, and it works for the popular programming languages like Java and Python and Node.js and a bunch of programming languages. Yes. No, this is development environments. But you mean to detect like vulnerabilities? If you run on Google Cloud, yes, I will show you. But if not, most of the stuff we have in our CI/CD pipelines are based on a project called Project GraphIS, which is an open source project. So there are ways basically where you can have continuous scanning on your artifacts when they are being built, either during the build process or after you have stored them in an artifact registry, right?
But is it only limited to Google sort of things?
So GraphIS is open source. You can use GraphIS wherever you want. What I'll show you is the integration we have done in Google Cloud, but GraphIS itself can work anywhere. Yep.
One thing as well that you can do is that you can actually create your own container with the actual image of the workstation at the base. You can also upload that container image to artifact registry. It could be then scanned for vulnerabilities.
Correct.
You can actually make sure that your development environment is always under scan.
Yes. That you can do that as well.
What if I want a Windows-based
What do you mean by like? You can use the JetBrain gateway. I'm gonna show you. You can have your remote environment be in cloud workstations, which is Linux based, but you can have a heavy client on Windows, Mac, or Linux. So the heavy client by JetBrain can be installed anywhere. I'll show you in a bit. Just let me finish this. So then we have introduced also, of course, we have vulnerability scanning in artifact registry. That's what Thomas talked about. When you store your images, we will continuously scan them for you. Or you can use GraphIS to integrate into your own container registry, whatever you're using. We have something called assured open source. So assured open source software are basically a set of dependencies that are, for now, Java and Python, some of the most popular ones that we will continuously scan, and we host them for you. You can use ours to pull dependencies from our artifact registry. So you can be sure that they are safe between codes, right? So that's another thing. And then what we did is we took this thing called Cloud Build, which is our CI pipeline, and we integrated SLSA compliance to it. So Cloud Build itself is SLSA 3 compliant. So it does all the stuff that the framework says have to happen for this to be called SLSA 3. And it shows you all of this in the interface. I'm going to show this in a bit. We have also added something called security runtime insights. So these are integrated continuous scan into GKE and Cloud Run that will scan your workloads and show you vulnerabilities and misconfiguration. I'm going to show you in a bit. Yes?
I'm just curious because like it was SLSA 3 compliant.
Yes.
Like you previously you showed that like the SLSA had 4 levels. Like for example, why not the 4th level like on this one?
Because the 4th level requires double attestation, and we don't do it because it's only one of us. We are the provider.
Okay.
If you want SLSA 4, you have to have a double blind attestation type thing.
And you usually don't need SLSA 4 unless you're like a bank or something.
Pretty much, yeah. Unless you are like some regulated environment, SLSA 3 usually is enough for most people. Then we have something. This binary authorization exists for a while. It's a way for you to configure your runtime environment using policies to automatically check for policies. So I can give an example. I'm not going to show it in a demo today, but an example, it can be, for example, here is you can only allow certain images to be deployed. So you can, based on certain paths, you can actually say images can only be deployed from certain artifacts registries, so that your Kubernetes cluster or your Cloud Run does not randomly pull an image from the internet. So the thing I showed earlier with signature, you can also have a policy on the cloud, on the GKE, the Kubernetes cluster, to say only pull images from a specific artifact registries, because by default Kubernetes will pull from wherever the internet is available for it to pull from, right? You can also have something that can continuously scan your artifacts, and then you can set up policies to say if it finds high vulnerabilities, don't let this thing be deployed. So stuff like that. So binary authorization is like a policy as code kind of framework. And so this is typically how like the whole thing will look like in our environment, starting with Cloud Workstation as your development environment, Cloud Build for building the images with the SASA 3 compliance, Artifact Registry for storing and continuously analyzing your images, Cloud Deploy, which I'm going to show earlier. Cloud Deploy is also SASA 3 compliant, so as a CD pipeline. Binary authorization for doing all the security checks, all the kind of policy checks. And then we have the security insights in GKE and also in Cloud Run, which I'm going to show in a bit.
One comment here as well.
Yeah.
Like one of the things in SASA 3 is that you have to be able to do a remote build. That is that you make a build and then you kill
the builders. Yes.
And that's actually not trivial to do on a standard CI/CD. So actually, Cloud Build and Cloud Deploy support this out of the box. And that's,
yes, because the way Cloud Build works is that each build step is a container that we will run, store the results somewhere, and then kill the container. And the entire build pipeline is just container, is Docker inside of Docker. So once the entire build pipeline is finished, we attach all the metadata to the image, like the software bill of material, how this image have been built. So we tell you which builder have been used, when, sizes, whatever, how much time it took, etc. And then we clean the entire environment. So thank you. I didn't want to go details into SASA, what it means, but good point. So I'm going to show you quickly how this looks like. This is how my demo is. I have an app which we use. It's called the microservices demo. It's basically like a web shop, like an e-commerce application. And this app is mostly deployed on GKE. All the backend services are deployed on GKE. And I'm going to show how the front end. So the example we say here typically is you have a new front end team. They don't really know much about GKE. They don't care. They just want to get up and running. What you can do is you can actually allow them to use Cloud Run to run the front end for the test and dev environment, and maybe the production would be on GKE. But I'm going to show you how we can use this entire pipeline with just the front end portion of this app. The app front end is deployed on Cloud Run, but it still talks to backends in GKE. So starting with Cloud Workstations, I'm going to show you real quick how this looks like. And of course, it stopped, obviously. So I have two workstations here that I have created earlier. One is using Visual Code. The way you would decide whether a workstation uses Visual Code or not is using something called configuration. So you create a configuration. In the configuration, you say which image is going to be used, whether it's IntelliJ, whatever of the IDEs, or your own base image. And then you create the workstations, which are just instantiations of the image, essentially. And the reason why we split configuration from workstations is to allow you to like roll out changes. So if you want to change a lot of workstations for a lot of people, you don't have to do changes per workstation. You can just edit the configuration, and then everybody just restart their workstation and they pick up the new changes. So I'm not going to go into details for this. I'm just going to show you my workstation. So I have a Visual Basic one and an IntelliJ one. Let's start with the IntelliJ one. So here I have a workstation which is based on IntelliJ as a base image. The thing with this one is that I cannot actually launch it in the web because this is a backend workstation. This is just the backend portion of the IDE. So what I have to do, or what I have done, is I have deployed something called JetBrains Gateway. I cannot make it bigger, sorry. It will hurt your eyes, but this is essentially a heavy client. It's installed on my Mac, and it has a bunch of plugins. And you can see here this little Google Cloud logo. So that's the Google Cloud Workstations plugin. So if I click on it, I have already configured it. I'm just going to choose which workstation I want to connect to. And then I will navigate into the folder I want to open. I think it's not very visible for you, a little bit. Then I just do connect. And so what this thing will do, it will connect remotely to my workstation, and it will load an IntelliJ looking IDE. Again, the entire IDE is in Google Cloud. What you have is just a client, right?
Your source code, that source code
Is also in the workstation, which is in the cloud. It's not local.
it's not in your
It's not in my local machine at all. Right. It uses some JetBrains proprietary thing. I would assume it's a combination of SSH and port forwarding. That's how the internet is built. Just a lot of SSH, and there's probably a proxy in the middle because you have to have a proxy. No, so that's the thing. It's not a Bastion host. It's you still have SSH to it. Now I have to find it. Okay, so this is my IntelliJ container. Sorry. How can I make this thing bigger?
Presentation mode, it should be.
I tried the
No,
regular.
it should, there is a thing called presentation mode. Go into.
It doesn't have a zoom in thing.
Yeah, and the first one. Enter
I tried what? Enter presentation mode.
There you go.
Okay. And now how do I get it out of presentation mode?
Same thing. Yeah. Appearance.
The reason I want to exit is I want to open the terminal. Hopefully I can make the terminal bigger. No. Command. It doesn't work. Anyway.
Pinch.
No. Anyway, I'm not going to use it for the rest of the demo. I'm just going to show you. This is a Linux workstation. You see, it's not on my MacBook. It says Linux there. Trust me, it says Linux, even if you don't see it. But yeah, it just looks and feels like a regular IDE, right? It looks like your regular IntelliJ. The whole thing is the code is not on my laptop. Nothing was on my laptop. It's just a gateway. It's just a client. It's basically like an RDP, but giving you access only to the IDE itself. Make sense? It does. Yes. So I'm using a trial license. So this is IntelliJ. That's basically like a local IDE with a remote backend. In my case, I'm just going to use the regular one. So this is the other one, the Visual Code one. It looks like Visual Code. Again, just showing you here. Again, it's a Linux workstation. It's not Mac. It's not Windows. It's running on my laptop. So the question earlier, if you want Windows, IntelliJ Gateway can be installed anywhere. The client, the heavy client, or the JetBrains Gateway can be installed on Windows or Mac or Linux, right? But otherwise, you can just work in the web. And this will also work on Windows as long as you are using a good browser like Chrome and not Edge. So here, what I have here is basically a very basic, this is the front-end code, right? It's the code for the front-end app. I'm not going to go too much into details. It does have a Dockerfile for building it. And it does have a CI pipeline and CD pipeline definition. I'm going to show you later. But let's start with the basic one. One of the good things with, you remember I told you earlier that the cloud workstation comes with Google Cloud Code built in. So when you have Google Cloud Code built in, you have a bunch of integrations with Google Cloud. Like you can, for example, look at all your Kubernetes clusters. You can do right-click, deploy to Kubernetes from the IDE. Or one of the things you can do is you can run a local emulator. Google Cloud Run has an emulator, and it's already available in cloud workstations out of the box. So if I want to run the emulator, in other terms, if I don't want to build my image, push it into a container registry, and then deploy it into Cloud Run, wait for it to be deployed, and then look at it, I can just go run on Google Cloud Run emulator. This is going to start, it will take a little bit of time, but it will eventually pop up a local host server, which serves my front end, and all the backends are on GKE, right? Again, all the backends are deployed on a Kubernetes cluster. One important thing here is that this cloud workstation is part of your cloud VPC. So if you are developing a microservice which has dependencies which are only available inside the network, you don't have to expose those dependencies outside to the internet because you're not working from your local laptop. You're working from inside the VPC. I'm going to show you how that looks like in my case. I basically have a services.env file. My front end has a bunch of dependencies, and each dependency is just an environment variable which has an IP address, and you see the IP address is private. So all the dependencies, all the backends are actually inside the VPC. They're just exposed so that my front end which is running on my workstation can access them. Nothing is exposed to the internet. Yeah.
I have a question. Is it, so we was talking about that it's possible to attack the code on using the package the dependencies. But is it possible to do the same thing, like using the dependencies to attack the developers' computers? Like, for example, we load the front end, back end, we run it on the machine, and if somebody put some vulnerable code to steal some kind of information from the developer's machine, it's technically possible, right?
Yes, if your dependency has a backdoor, yes. When you run it
So
locally.
that could make a lot of sense to work like remotely, so don't have any kind of access to local machine.
Correct. Yes. Yes.
Yeah.
Yes.
One thread that's actually underestimated is the actual extensions that you install in your
IDE.
IDE.
Yes.
Because they usually just install it because it's cool and you check where it comes from. And that has access to all the code, all your password.
Yes. So in my case, my workstation is public. When you create workstations, you can decide if they are public or private. So if they are public basically means the workstation itself is accessible from the internet. And that's what I did because I don't want to set up VPN and stuff. But you can also make the workstation itself private. And in which case you have to be physically connected to the corporate network of your company through VPN or through proxy, in order to access your workstation. So you, in other terms, you can make this workstation completely isolated from the internet, right? And you can also itself, if the workstation is private, it means that it cannot even pull from the internet. So if you want your developers to be able to pull dependencies only from internal artifacts registry or a dependency manager, if you have like a self-hosted Maven, for example, for Java, then you can do that. You can, as long as that dependency package manager tool is inside the VPC, then you can make your application just pull dependencies internally, and you don't need the internet.
Yeah, well, but the reality is that projects use a lot of
Open source code.
from the open source code.
So typically what our customers would do, or what an enterprise that cares about these kind of things would do, is that they would have an automated way to have developers say, I need this dependency, and then that dependency would be pulled and vetted and verified before it's available internally. So for you as a developer, it's an extra annoyance in the sense that if you find something on the internet, you cannot immediately use it. You still have to make it kind of get pulled. But it's possible. It's a lot of work, but it's possible to like automate this entire process for making sure that your dependencies are not vulnerable.
Yeah, I heard about the project called Sync. If you know that, they check the dependencies.
Yes, SYNK.
Yes.
Yeah. Snick. It's Brian, right? Yeah.
And they check the dependencies for this.
That's also is possible. That's one other thing you could do.
There's
Yeah.
a bunch of, most of the artifact registries do that now.
Most of the artifacts like extra Frog, JFrog does that.
JFrog does that, Snyk does it,
Sonatype nexus.
Sonatype does that, you have output set,
Or-
a bunch of them.
The thing which is part of CNCF, Harbor, does also that. So, yeah, there's a question.
It's also to mention depend on if you're using GitHub.
Yeah.
Check dependency.
Yeah.
Yes, also, yes. So I have my local host running, and now I have just my front end. So this front end is running on an emulator on the workstation, and I just have like a port forwarding for port 8080, so I can look at it. But all this stuff is in the cloud. Nothing is deployed on my laptop. Make sense? So now let's say that I want to do some changes, because that's what I do as a developer. By the way, when you run the emulator, it actually keeps running the backend, so you don't have to stop it. You can keep changing your code, and it will detect on changes. So I can do GDG Oslo, hello GDG Oslo, and I have to, once I save, it will automatically rebuild the front end, and then eventually it will show here. This actually, by the way, under the hood, it uses something called Scaffold. Scaffold is an open source command line tool for building container images. And when you run the emulator, it runs Scaffold in dev mode. So it monitors file system changes and just updates the image each time you are changing code in your code repository. Make sense?
How does this client work in case of flaky networks? Like if you're on train and just editing your code, will it buffer the changes or just tell you please wait?
It's as good as your internet is. I would say. It's as good as your internet is. So, but this is entirely in the web. So as long as you don't refresh the image, if you have a flaky network, it's not gonna, as long as you don't refresh the page, it's not gonna do anything, but it will try to reconnect if it's disconnected. Sometimes if it's disconnected for a long period of time, it will prompt you with like a window to say reload once you have internet again.
So you are effectively using a compute in Google Cloud.
Pretty much. It's a container, but yes.
So it will cost you as well, right?
The cloud workstations come with the cost, but not right now it's free because it's in preview. Right? It will be free all the way until before it's GA. Once it's generally available, then it will cost money. But right now it's in preview, then it will go to beta and it will be free for a while. So you can experiment with it for free. If you are a Google Cloud customer, you can talk to your sales team and they can give you free credits to use it. So say I'm happy with my changes, right? And I want to commit this code, this change. I'm too lazy. I'm not going to use the terminal. I'm just going to go say awesome commit message here. One of the most useful commit messages ever. And then I will just push my code. So this will push my code to my code repository. Again, I'm not using GitHub because I'm too lazy. I just have it on the hosted GitHub thing you have in Google Cloud, one of the shittiest versions of GitHub. But anyway, see, my commit code is there. Now, what I have also is I have a cloud build pipeline defined. If you have never used cloud build, don't worry too much if you don't know what it is. It's a CI pipeline that uses YAML, everybody's favorite programming language. It basically has two steps. The first step is Docker build, and the second step is triggering the cloud deploy. So I have a cloud deploy pipeline, which is a CD pipeline that has dev, stage, and prod. And what I do is each time I change code and commit changes, I build the image, push it to artifact registry, and then I deploy to the stage, to the dev environment, right? So it's two steps: build, deploy to dev. So right now, I know that my build pipeline have triggered because I did committed some code. So I go here, I see that there is some stuff happening. It's going to take a while, so I'm going to come back to it in a bit. I'm going to go back and show you one other feature, which is actually pretty cool in my opinion, which is the security insights, the runtime security insights. So I'll have to switch to my project here. This is my cluster with where the backends are deployed. Again, don't worry if you don't know what GKE is, but if you do, you might have noticed that there is a new tab called Security Posture. And if you click on it, it shows you a very awesome dashboard. As you can see, the open source software we have is very, very clean from vulnerabilities. But this dashboard basically shows you an aggregated overview of all your dependencies and misconfiguration in your GK cluster. And this is continuously scanning. It's not like a one-time, it's not on deployment, it's continuously looking at your workloads. So I can go here, and I can filter by vulnerabilities. If I click on a specific vulnerability, it will tell me which workloads are affected, so which workloads have this specific vulnerability. But it does also look at configuration misconfigurations. So if I go here, I see this filter here that says configuration. If I click on it, it says, oh, what do I have? I have a pod with a container which is allowed to do privilege escalation. If you work with containers, privilege escalation is basically when somebody either uses a container that is root with a user root, or uses a container that can just do sudo with a user that can do sudo. So that's privilege escalation. So here it says these three images can escalate their privileges. The container can do privilege escalation. And then it gives you even ways to mitigate this. So it tells you have to edit your YAML file and change or add this stuff, right? So it's straight from the GUI, and it works both for a GKE and Cloud Run. So the security posture is available for both. Make sense? So somebody asked me usually this question, is this available through API? Not yet. It's coming at some point. So this is just GUI based for now. It's only visualization, but eventually it will be available through an API, and then you can build like alerting around it. You can build, even policies that says if something is vulnerable, don't let it be deployed, blah, blah, all the good stuff that people want to do. Again, this is in preview, so it's free for now. Yes?
So you showed us the Google Code Cloud, which only works for like Java and Python packages.
That's the assured open source, not the Google Cloud. So, yeah.
So will it also fetch results? Like we will also get the results from that here also?
No, assured open source, what it is, essentially it's a set of libraries which are tested by us and are hosted by us. So instead of you pulling the libraries from Maven, for example, you can pull it from our own Maven.
Got it.
Does this make sense?
What if I want to use a library which is not in your Maven,
Yes.
but outside, and I want to make it secure? Do I have to use like other tool like dependency check or sonotype? Or?
Yeah. So what you can do, I'm going to show you in a bit. So this is the results of my build pipeline. So this is the 2 steps I showed you earlier, building and triggering the deploy pipeline, right? If I go to the build artifacts, I can actually look at the security insights here. And so this will show me vulnerabilities. So this is what you're looking for. This, what it does basically is during the steps of building the image, it scanned it and it shows you vulnerabilities. So if you have a vulnerable image, it will show in Cloud Build. It will also show in Artifact Registry. I'm going to show you in a bit. But this is the SALSA Build 3, Level 3 compliance I talked about. This says, so scanning vulnerabilities is part of the requirement for SALSA Level 3. But another thing is this thing called provenance. So part of this framework called SALSA Level 3 requirements is that when you build an image, because this build pipeline is ephemeral, as Thomas said earlier, what you have to do is you have to attach metadata to the image that says how this image has been built. And that's what we call a provenance. You can think of provenance as the recipe to make a dish. Provenance is the set of steps that you have followed to make the dish. The dependency or the SBOM, the software bill of material, are the ingredients, the individual dependencies in your case, right? So here I have which worker have built it. So this is like a Google hosted worker, because the reason why we have Google hosted workers is because Cloud Build supports self-hosted workers. So you can host your own images that are the builders. But in this case, we used our own builders. And it has a bunch of metadata like the timing, when did it start, when did it stop, the success, what are the steps, so the actual individual command lines that the build pipeline run, etc., etc. Where it was run, you can see here it was run on a verified E2 high CPU memory thingy, whatever. That's the worker, because I configured my workload to run on my build to run on 2 CPUs, 8 GB of memory, or 16 GB of memory, whatever that is, just to make it faster. And I realized maybe this is not good enough to see. So you can see basically the provenance are the set of steps that have been followed to build this image. And that's attached as metadata. You can either see it in the Cloud Build pipeline, or you can actually go and look at directly the artifacts. Where is the artifact? Oh, yeah, we can look at the image here. We can go to, this is Artifact Registry. It will show you all the vulnerabilities. So this is the continuous scan I talked about earlier. And then it has the provenance somewhere. Where is the provenance? I don't see it. It does have the, what is the, it's somewhere here. I don't see it now.
But this will be open source always, or?
No, this is based on open source stuff, but it's Google hosted. It's a managed solution, but it's based on open source, right?
Like I'm very new to Google Cloud, but for example, say if I'm using Google Cloud to deploy and work on this, I will be having access to this also, like the list of vulnerabilities and everything. Or is it a paid solution within Google Cloud also?
Well, you pay for Artifact Registry to host your images, and the vulnerability scan is part of the service, right? Does it make sense?
Yeah, so similar to like if I speak in Microsoft terms, you have Azure Container Registry, but there is something called Defender for Containers, which scans your.
I'm not very familiar with this, but pretty much the same thing. We don't charge extra for vulnerability scanning, right? We do? Okay. How is it too much?
Yeah, that was the question I was asking. That was the question I was asking.
Is it a lot? Okay, so it's not a lot. It's worth it? Okay. Thomas is in sales, so he knows.
Do you have open source alternatives?
Yeah.
Yes, of course.
How will they now have a Graph and Sift? And if you want to scan things in Kubernetes, you have
you have a lot of them.
Dependency track, and you have also Open Clarity, or sorry,
Yes.
Kube Clarity.
Yes.
Which I would recommend.
We have customers that are kind of migrated to this. So basically, they are using all the sets cloud workstation for an Artifact Registry as their repo, and then they're actually putting the sources from other clouds as well. So they don't do the CI or the deploy from GCP, but they still use this as a vulnerability scanning.
Yeah, or we have also customers that doesn't even store stuff in Artifact Registry. They use their own Artifact Registry, like JFrog is one of them. JFrog has a managed version, so you don't have to store everything in Google Cloud. You can still deploy to. Sure. I mean, is it deployed on, where is it deployed? On AWS? On Azure?
No, In-house.
on in-house on-prem. Yeah, sure. We have customers do that as well. So all of this is the way I like to describe this thing. Everything is API driven, so it doesn't really matter where your stuff are stored. Everything is container images. Container images is standard format. It's OCI, and then Kubernetes can run things. Cloud Run can run things as long as they meet the requirements. So where do you store your image? How do you scan the dependencies? How do you scan vulnerabilities? It doesn't really matter, right? I am not tracked on cells, so I don't really care if you use this stuff. So,
I have one question.
yes.
So let's say I'm a developer,
Mhm.
I'm building an image to deploy in production,
Mhm.
but by mistake, I have checked in some sensitive data. Let's say, for example, I have a private key, and
Yes.
I have added that private key as part of my image by mistake.
Yeah,
Will this scan catch?
I don't think so.
That is
Vulnerability
secret-
scanning.
secret scan, that is not vulnerability.
Yeah.
You need
Vulnerability scan is pretty basic. Vulnerability scan for images checks the MD, the checksum of a layer in the Docker image against the CVE database. So it doesn't really look for secrets and stuff like that. So you need to have an extra something else. Yes. Typically, that would be part of your source code. So part of your GitHub repository, you can install something there that checks for secrets and stuff like that.
Yeah, this is a big problem I have because I cannot prevent my developers to check in secrets in the source code. They always
Are you using GitHub?
no
Oh, okay. So
in-house. We have in-house in our private
a
network.
lot of secrets. can be
Yeah, there are a lot of secrets to be there, and I don't know how to prevent them. There should be. Is there any tool which
There
can
are
just?
lots of secret scanning tools are there,
Yeah.
but
I'm sure there are, but I don't know if they are available for the kind of source repository you use, right? GitHub has a lot of them. So Git or GitHub, whether you are using GitHub, the managed solution, Git Enterprise, or self-hosted Git, there is quite a lot of like open source tools you can run against Git to check for secrets. I don't know, like, are you using what, Piper or like?
Azure DevOps on-prem. So we are using on-prem Azure DevOps.
Well, that's Git based, right?
that is
Yeah.
Yeah, so
Git-based.
it's Git. So just get something that can scan Git for secrets and scan your source repositories, I guess. I don't know how Azure DevOps works, to be honest. So
It's basically same thing as GitHub, probably.
just or migrate to Google Cloud. Yes, there was a question there.
Yeah, at this moment, you basically, you're not stopping anybody from doing something stupid, are you? You're basically just documenting how you're shooting yourself in foot.
Yes, so this is very good. That's a very good point. This is part of this shift left thing that I told you about, because this stuff, the whole point here is this stuff will be available for everyone to look at, right? Now, how do you prevent people from doing stupid stuff? Can be done in various formats. You could take a very simple example. You could take binary authorization, which is a managed policy as code software, and you can configure it to say if things has vulnerabilities, don't allow them to be deployed, right? You can. Do we have an I don't think we have an automated alerting for vulnerabilities. No, we don't. And I would say probably if we do, that would be stupid. So, like, I mean, you could also write your own thing which scans images continuously, and if it finds vulnerabilities, notifies people. That's possible as part of typically what people do for CM. But the issue is you are going to have vulnerabilities year to yes. So eventually, if you start alerting on every single thing, it's going to be a problem because you will have like we call this like a on-call overload, where you're just over-alerting people on stuff, right? So I would say the easiest way to think about this is use something that will use this vulnerability data as an input to prevent people from deploying shit that has vulnerabilities. So you're not going to prevent them from pulling stuff that is vulnerable, but if they try to deploy, it's not going to deploy, so they have to fix it. Right? Does that answer your question?
Yeah, so it doesn't really, well, how do you actually stop people from first? Is there a policy here that I can deploy or?
Not in vulnerability scanning, no. Not in the artifact registry, but binary authorization, yes. You can use binary authorization to prevent people from deploying stuff that has vulnerabilities. No, so binary authorization is an automated system. It's a software. It's an automated tool that can take as an input vulnerabilities, and then based on the policy you configure, prevent stuff from being deployed if they contain vulnerabilities. If they either contain certain level, like high vulnerabilities, don't let them to be deployed, or if they contain specific CVEs. Make sense?
Yes.
Or another thing is binary authorization has a way where you can only whitelist certain repositories. So you can say, my GK cluster, no one can deploy stuff that is not coming from this set of repositories, of registries. So that people cannot deploy things from Docker Hub, for example. Does this make sense?
Just want to say that you cannot have a policy that denies
Pushing.
with deploying artifacts with vulnerabilities, because sometimes you need to do a quick fix of something that is running, that is vulnerable, but it wasn't vulnerable at the time when they deployed it, because vulnerabilities evolve. So you may have an artifact that wasn't vulnerable yesterday, but today it is.
Yes, that's a very valid point. And so that's a very valid point you're making. So what if you have vulnerabilities at runtime that were not vulnerabilities when that software was pushed? Well, this whole thing is based on two concepts. We are introducing the security insights, which luckily was hopefully the idea is to continuously scan things at runtime. And eventually that feature will evolve into being integrated somehow. So you could alert maybe when something is vulnerable. But also, this whole thing is based on the concept that you're constantly pushing software. You're constantly changing certain software. So eventually, if a vulnerability is detected, that was not the case before, somebody will need to change code in that specific microservice or that specific application, and then your policy will catch it up. Does this make sense?
Yeah, for sure. The trouble is that to fix a vulnerability, maybe that takes 2 or 3 days, and then in the meantime, they cannot deploy.
Oh, yeah. Okay, I see your point.
That will be a problem.
Yes, so binary authorization have a way to bypass policies. If that's where question, like, what if I have vulnerabilities blocking me right now, and I need to still push code even if it has vulnerabilities? Binary authorization does have a way for you to say, like, okay, I allow this workload to be deployed, even if it does have vulnerabilities. So there is a way you can bypass policy. Make sense?
Yeah. That's
okay. So back to so we looked at the security runtime thing with the security insights. We looked at the cloud build thing, which is the CI part. Now my CD pipeline. So this is my delivery pipeline, which has 3 steps: dev, stage, and prod. So I already deployed to dev. You can say it says like 5 minutes ago. So that's part of the CI. The CI built an image and then deployed it. And then what I can do is I can promote it into stage. So I'm gonna do it. It's gonna take a little bit of time. So I'm not gonna wait for it to finish. But basically, I can manually promote it because I looked at it and said, okay, well, my dev environment looks good. But then if sorry, I should have clicked this button, not this button, but it's fine. So here what I did is I promoted from stage to prod a previous build, not the build I did 5 minutes ago. But this is good because I can show you the approval stage. The whole point here is I have 3 steps. I push to dev whenever I build. So that's the first step. Then I can look at my dev environment. So all of this stuff is deployed into Cloud Run, by the way, which I can show you here real quick. So I have 3 Cloud Run services, dev, prod, stage. And if I look at the dev one, and I look at the link, it's the change I made earlier, hello GDG Oslo. So this is the change I made that ran on the emulator, and then I pushed it to dev. But if I go to my stage environments, it's going to be saying something else, because this was the last time I was in Finland and I did demo there. So I haven't promoted it into stage, which is fine because it takes time. So I don't want to show the whole thing. It's going to take time. But basically the point is I can click promote to promote to stage. And then now what I did is I clicked promote to promote from stage to dev to prod. But from stage to prod, I added a review step, like a manual approval step. So somebody with the proper IAM permissions have to go here and approve a build or approve a promotion. And that should trigger the last step. So this basically means that I have promoted something from stage to prod, somebody have manually approved it, and then now it's eventually going to be deployed in prod. Make sense? There is one crucial thing I haven't actually mentioned earlier, which is like one of the bases for software supply chain security. As I was doing this thing of promoting from dev to stage, from stage to prod, I did not rebuild the image. It's the same exact image. And this is part of like do not rebuild artifacts as you are moving them from one step to another. So it's the same exact image, it's just being deployed in different targets. Make sense? And I think that that's actually the end of my demo. And I'm a little bit over time. I'm actually way over time. So I just want to go back here and say, well, thank you. I hope this was useful.